we want to solve the given equations with rational exponents. For the first equation, we have the quantity x plus 2 raised to the power of 5/3 equals 32. Notice how the part of the equation raised to the 5/3 power is already isolated, and therefore the first step is to raise both sides of the equation to the power of the denominator, which in this case is 3. So the first step is to cube both sides of the equation, which will clear the denominator from the irrational exponent. Notice on the left we have powers raised to powers. When we have powers raised to powers, we multiply the exponents. So if we want, we can think of 3 as 3 over 1. When multiplying 5/3 and 3 over 1, the 3's simplify to 1, leaving us with an exponent of just 5. So the left side is now the quantity x plus 2 raised to the 5th equals on the right 32 cubed, which is equal to 32,768. The next step is to undo the exponent of 5 by taking the 5th root of both sides of the equation. And because the exponent here is odd, we will only have one solution. So we take the 5th root of both sides of the equation. On the left, the 5th root of the quantity x plus 2 to the 5th simplifies to 1 factor of x plus 2. We can also think of the 5th root as undoing the exponent of 5. On the right side, we have the 5th root of 32,768. Which is equal to 8. The next step is to subtract 2 on both sides of the equation to solve for x. Simplifying, we have x equals 6. And let's check this by substituting 6 for x back into the original equation. If we substitute 6 for x, we have the quantity 6 plus 2 raised to the power of 5/3 equals 32. Let's just verify the left side of the equation is equal to 32. 6 plus 2 is equal to 8, giving us 8 raised to the power of 5 divided by 3, which is equal to 32, verifying our solution is correct. And now let's take a look at our second equation. For the second equation, the first step is to isolate the quantity 2x minus 1 raised to the 2/3 power by dividing both sides of the equation by 3. Simplifying on the left, we have the quantity 2x minus 1 raised to the power of 2/3 equals on the right 12 divided by 3 is equal to 4. And now the next step is to clear the denominator of the rational exponent by raising both sides of the equation to the power of 3, which is the denominator. Because we have powers raised to powers on the left side, we multiply the exponents. When multiplying 2/3 and 3, notice how the 3's simplify to 1, leaving us with the quantity 2x minus 1 raised to the second power. On the right side, we have 4 cubed, which is equal to 64. The next step is to undo the squaring by taking the square root of both sides of the equation. But here, because the exponent is even, we are going to have two solutions. To obtain the two solutions, we need to make sure we include a plus or minus on the right side when taking the square root of both sides. So we square root the left side and the right side, but then include a plus or minus on the right. And we do this whenever the exponent here is even. Now simplifying, the square root of the quantity 2x minus 1 squared is equal to 1 factor of 2x minus 1. And on the right side, the square root of 64 is equal to 8, giving us plus or minus 8. The next step to solve for x is to add 1 to both sides. Simplifying, we now have 2x is equal to, let's write the right side as positive 1 plus or minus 8. And our last step to solve for x is to divide both sides by 2. Now notice how because of the plus or minus, we are going to have two solutions. Simplifying, one solution is x is equal to the quantity 1 plus 8 divided by 2. And the other solution is x equals 1 minus 8 divided by 2. Simplifying, 8 plus 1 is equal to 9. We have x equals 9 halves. And then for the second solution, 1 minus 8 is negative 7, giving us x equals negative 7 halves. So for this equation, we do have two solutions. We have x equals 9 halves or x equals negative 7 halves. And again, let's go ahead and verify these solutions by substituting 9 halves for x and negative 7 halves for x. Substituting 9 halves, we would have 3 times the quantity 2 times 9 halves minus 1 raised to the power of 2/3 equals 12. Substituting negative 7 halves for x, we would have 3 times the quantity 2 times negative 7 halves minus 1 raised to the power of 2/3, again equals 12. And let's go ahead and verify both expressions on the left are equal to 12. Notice both expressions are equal to positive 12, verifying both solutions are correct. I hope you found this helpful.